Today we're going to talk about the string class. In Java, we only talked about the string class. And you know enough about classes to understand that somebody created this class, this data type, string, and all of the methods that go with it to make life easier for us. And here's the pound include string. You know, we did a little work in our Java class, learning how to create a class, and we put our methods in there and our constructors and those types of things. So somebody created the string class for C++, just like they did for Java. We've been using strings a little bit up to this point, but I need to have the import statement hashtag include string. Just a simple example. I got a couple extra T's in there. Cout name, get line cin name. So I can read in an entire string. Again, we need to be careful when we read in, making sure we don't read in up until the first delimiter. What is the first delimiter in a string? The space, right? Remember, it was just giving us the first word instead of the entire sentence. So cin get line is going to help us read in an entire sentence. The nice thing about working with strings in C++ is I can use the actual equals operator. What was it in Java? Some of you remember?
Compared to?
Compared
Yeah.
to was one choice, and that returned either a -1, 0, or 1. But the one that we used most was equals, right? We were able to actually do the equals. And you know, you did code listing 1017, and in here you actually were doing the equals. Part number equal a string literal. So it was like, yay, I could finally get back to doing that. The relational operators. The relational operators are great. I can compare strings. Is Mary greater than Mark? You know, and that's the whole capital M-A-R. Is that greater than capital M-A-R-K? And the answer would be it's either true or false.
True.
True. Yep. It would compare the M's, the A's, the R's. When it got to the Y, this Y is greater than that. Again, it goes back to the ASCII numbers. And we remember the relational operators. Less than, greater than, less than or equal to, greater than or equal to, and not equal to. We had all of those going on. How are we doing with questions? Okay, again, you're familiar with strings, and I have a note over here, string class. Does anybody know of a good website, or are we all using the same ones? Like if I said, oh, a good website is, I'm going to pause my, so as I just said, C++, C++, is a really good website. Do any of you have any that you reference? Don't say Stack Overflow, because I just had to withdraw 2 students who decided to use Stack Overflow on their last program. And, you know, it's like going on Chegg and stealing stuff. I don't look for it, but I eventually end up catching people just because they just do dumb stuff. No, nobody else has a good C++ website. That's fine. That's fine. I'll move on. Okay. This table 10.7, all right, declaring a string. Some examples, we really don't ever need them because we usually would just say string name equals double quote Bob, right? Assign a string literal right away. But as you can see from this table, when you read the book, I can do string name, and it looks like I can pass in an argument that assigns to name right away. It's almost like working with a constructor of a class. No, wait, string technically is a class, right? String person1, I can not only pass in a string literal, I can pass in a string. Wow, it looks like the constructor for string is really over
Overloaded.
thank you, overloaded, right? No parameter, single parameter. Here's two parameters. The first one is a string. The second one is, in this case, 5 characters would get copied over. Here's, in this one, it looks like it's overloaded. Here's a character followed by an int value that says take the first 10 spots and fill them with characters. So, wow, looks like they gave us a whole bunch of different, when they wrote the string class, a whole bunch of constructor options that we can use. Somebody say, ooh,
Ooh.
like fireworks. It's not that hard. Nobody? Julie, say ah. Somebody say ah. Thank you. Thank you. Okay, concatenating strings. Here's an operator plus. We know we can add strings doing concatenation with plus. This plus operator is overloaded. When you take 162, you'll get into a bunch of overloading for that. All right, so I just talked about, do you have a favorite website that you can look up examples? Yeah, they put a whole bunch of them in the book to show you some crazy ones that are going on. Your favorite one is length. That's a big one. Here's a compare. We wanted to compare. There's a copy. There's a find. Find is kind of nice. Insert is good. Like I said, length is our favorite. There's replace. So almost anything you can think about doing to a string, there's probably a method written for it. You would just need to go and find it. Length dot find, like I said, is good. Dot replace is good. Extra for experts. In this book, every once in a while at the end, they'll put an in the spotlight and they'll give you a little bit of extra for experts. This one's talking about string tokenizing. Back in Java, when we covered chapter 9, we only did section 9.2, which was characters, and 9.3, which was an introduction to string functions. Okay. Also in that chapter, there was a lot dealing with tokenizing and how you can read a string in and break it into certain tokens. Okay, the tokens would break up according to, like, my delimiter, as I called it, is a space. So you could work with a string until you found a space. Or down here, you could work with this delimiter being the dash, where you could read until the dash, read until the dash. It would help you to break a string apart. So the ComSci gurus and experts, not a bad section to look over. String tokenizing. And again, some of you may already be a little bit familiar with what's going on there. Any questions about strings? Okay. For today, I want you to write this program. I have STOI written at the top. What was STOI? String to int, right? It was my function that was written that we looked at in the last section that talked about A to I was a character string to an int. And quite a few of you, I had to call the class back and remind you that this single quote A is a character. That's not a character array to be able to turn it into an int. So we couldn't use A to I on that, even though a lot of you were trying to break it up with your char at. Okay, so that was a no kind of deal. But here's what I want you to do. I want you to create a data file. data file is going to have number of students. For example, 4. Then it's going to have the name and 3 test scores for each student. Bob, 20, 40, 60. Chet, 3 scores. Another student, 3 scores, and another student, 3 scores. So you're going to start out by reading in the number of students. That number is going to be golden for you. 4. Great. I need that number. Okay. You're going to read them all in. Now, you don't have to store them in arrays. What I want you to do is, inside of a loop, display the name and the average for each student. If they have the high score on one of their tests, store that and their name. If they have the shame of having the lowest score on one of the 3 tests, store their name as well. But also, while you're in that loop, display, or excuse me, after all that, when you come out of the loop, you're going to display these 3 things: the overall average from the 4 students and their 12 total test scores. What I want you to do is minor practice with STOI. I want you to input all the strings, everything as strings. So when you input the 4, you're reading it in as a string. You're going to have to convert it to 4 using STOI. You're going to read in the name, then you're going to read in 3 test scores as strings. So everything's going to be read in from this data file as strings. You know, we worked up to this point with data files reading in just integers or just data, but you notice we have mixed types here, but I want you to read everything in as a string. Anybody need to get a shot of what's going on there? Yes, no, maybe? Ooh.
Professor, before we break out real quick, when it comes to the shell sort, how is it any, because it comes back to a linear search or a linear sort at the end, correct?